Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of it, you will have the opportunity to listen to it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question, and we'll try to get to as many as we can before the end of today's webinar. Also at the end of today's webinar, we will be doing a drawing for two $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our 2 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is 3 pillars, no answers, helping platform teams solve real observability problems. Our speaker today is Austin Parker, who is Principal Developer Advocate at Lightstep. Austin, thanks so much for joining me this morning. How are you?
I'm doing great. How are you?
I'm doing great. Hopefully you're working on your second cup of coffee at this point.
Always.
Yeah, all right. Well, I'm going to put myself on mute, let you get right to your presentation.
Okay, great. Well, let's go ahead and get going then. First off, good morning, good afternoon, good evening, whatever time it is for you. It's 8 a.m. for me, so like I said, I'm working on my second cup of coffee right now. I'm Principal Developer Advocate at Lightstep. My job is really to talk to developers, talk to people that are interested in observability, help them understand, what it is, how they can implement it, how they can instrument their software. You can find me on the internet. I'm on Twitter at Austin L. Parker. It's probably the best way to tweet at me. You can also email me, austin@lightstep.com, if you have any questions. But that's kind of the basics. I've been doing this for a couple years now, working in observability specifically. Before that, I worked as an architect on a DevOps team for a distributed software company, and done a lot of other things in my life, from anything from IT to telecom to short order cook. So a lot of interesting jobs. So today we're going to talk about observability, and the first section of this talk is really a critique of the modern monitoring space in a lot of ways. So first, there's this conventional wisdom, right? We all know that observing microservices is hard, and really observing any kind of service behavior in production is hard, right? But microservices had a lot of challenges. If you've deployed microservices into production, or even if you've done sort of a proof of concept, this is something that maybe will ring very familiar to you. Now, there's a sense that larger companies in our space have solved this problem. Companies like Google and Facebook, they use a blend of metrics, logs, and distributed tracing to solve these problems, and we should do that too, right? That's the essence of the argument that a lot of, companies and a lot of vendors will tell you. But it's not really based on this understanding of the problem from first principles. In general, we shouldn't be blindly emulating what Google did. Google was dealing when they implemented tracing, certainly, and a lot of their monitoring stack, they were dealing with problems of scale that most companies, most people that aren't Google will never see. Google was processing and is processing, I believe, about 5 billion RPCs per second, right? If you're going to build a system that's going to observe 5 billion RPCs per second, there's a tension between the scale and sort of the feature set that you can build there. You're going to give up features to scale to that volume. The solutions that we can use outside of Facebook and Google and Amazon and Netflix and so on and so forth, are often a lot more powerful from a feature standpoint because we don't have to scale to an order of that magnitude. This conventional list, or 3 pillars, is really dogmatic, right? You can go read any number of blog posts that say, hey, here's how you do observability. You get a metrics stack, you get Prometheus, something like that set up. You get a logging search and logging indexing with something like Elk stack, and you get a tracing system, something like Zipkin, Jaeger, whatever. You put those in, you wire them up with data, and you're done. Problem solved, right? I think the reality is a little more complex. So this is what metrics is. It's a lot of squiggly lines on some sort of time series scale, right? You're probably pretty familiar with metrics, so I'm not really going to go into it in a ton of depth, but you have some sort of statistical measurements about your software or about your system. You sample them very frequently, and then you draw lines from those samples. You can plot those in various ways. We see here bar graphs, stacked line graphs, so on and so forth. But at the end of the day, these are just some statistical measurements taken in very frequent samples, and then we are putting them onto a time series. Logging is the second of these pillars. And again, this is something that most people have a very firm understanding of. At the lowest level of logging, you have statements in your code that you're writing data to. Those get emitted to, that data is either structured or unstructured, right? So it's, some arbitrary string, or it's some sort of log object that gets emitted to a file or to some sort of centralization indexing system. And then you can search over those log files to generate a list of logs. And then you can also get some statistical frequency as well, right? And we see in this Kibana graph where we have this bar chart of showing logs per second, or count of logs over some period of time. Finally, you have tracing, and this is usually, when I say tracing, this is usually what people think of. They think of this icicle graph, right? This is Zipkin. There's a lot of other tracing systems that visualize distributed traces, but there's a couple common elements. A shared timeline, the fact that each of these trace segments comes from a different part of a distributed system, so a bunch of different services. And you can also look at this to understand, what caused what, so you can sort of follow the critical path of a request as it goes through your distributed system. And when we think of things, we like to think of things in threes, snap, crackle, pop, Neapolitan ice cream, Larry, Moe, and Curly. It might be that the reason there's 3 pillars is because we just like things that are sets of 3. Who knows? But more seriously, we as people that are using tools, as professionals that are trying to build and run complex software systems, we get frustrated by people that promise things in terms of either use cases or value propositions, and we want those things to be factual, right? We want, someone says, hey, do you support metrics? Do you or don't you support logging? Those are objective measures that you can assess and grade an observability solution, and that has a lot of appeal, right? This sort of checkbox idea. But those all have fatal flaws, and it's hard to get people, when you are doing a webinar or you're going to a conference or whatever, it's hard to get people to talk about what doesn't work. And I think, we really need to do that. All systems have trade-offs, right? So let's start talking about the trade-offs in metrics. So in 2015, this wasn't as big of a problem, and it's been 5 years, and I think, we can really start to talk about this cardinality problem, right? So we have tags or dimensions, and those tags can explain variances in time series data. So what we're looking at here is a time series This is real data from one of our internal systems at Lightstep. Now I can look at this and I can see that around 1300, 1 p.m. there's some sort of anomaly happened. This time series looks different. So if I'm looking at this, if I'm on call and I see this line go up, my question is obviously what happened? Well, we need to refine this data more. So I have tags on my time series and I can group by that tag, and now I get a new set of lines where I can see that that anomaly came from one particular value for the tag, which is what you see on the bottom graph here, right? It's not a root cause, it's not, the problem, but it helps me investigate the problem because now I know that this tag value is highly correlated with the problem. This is extremely useful, but there's a issue with it, and that's that the number of values for the tag is expensive. And the number of unique values for that tag is what we call cardinality. This cardinality is part of a product marketing for a lot of companies because it's a very big pain point when it comes to metrics, right? How do you deal with high cardinality metrics? Now let's move on to logging. So the problem with logging, sort of the fatal flaw there, is the cost of the data itself. When we're kind of in general, I think most traditional monitoring systems are going to find that logging is one of the most expensive parts of their sort of observability platform, right? When you're dealing with a monolith and you have a pretty simple sort of calculus, which is I have a certain fixed number of logging statements per request through my system, and so I can just multiply that number of logging statements by the number of requests, and I get this is how many gigabytes of logs I need to process a month. Well, when you make this, when you turn this into a microservices problem, sorry, when you turn this into a microservices problem, then it gets more complicated, right? Because now I have to deal with the fact that my requests are traversing a lot of different service boundaries. So if I want to use logging to understand those requests, I need to log more places, so at every entry and exit point from the service, and then I need to multiply the request rate by every microservice. If I build out a microservice stack and I go from 10 to 100 to 1,000 microservices, my logging cost is going to scale roughly linearly in a linear fashion with the number of services, which is a problem because the value I'm getting from those logs is not scaling at the same orders of magnitude. The total logging data volume, when you include the cost of networking to sort of exfiltrate and centralize those logs somewhere, and then how much it costs to store them, multiply that by however many weeks of retention, gets extremely, extremely pricey very, very quickly. And Google solved this in a certain way, right? So Dapper was a tracing system they implemented at Google. Our CEO at Lightstep worked at this system, worked on Dapper. And in a lot of ways, Dapper was a response to the cost of logging more than anything else. So they solved this problem with sampling. So they didn't sample blindly. Instead, they would look at a single transaction or a single request, and they would sample the entire request. So they would say, this entire request goes in, these 10 requests go out. Instead of sampling every single log statement, they would sample that entire request and then figure out, hey, do I keep this or do I throw it away? By keeping 1 in 1,000, they were able to significantly reduce the cost of getting the data out of the process and into a regional storage. But this wasn't enough because they had to do another 10x reduction in the data to get into global storage. So after all of the various samples, they had 1 in 10,000 requests stored. The other 9,999 were discarded without consideration. So the sampling was effectively blind. This was a problem at Google because outliers, by their very definition, don't happen very often, and you would probably lose it. Similarly, if you wanted to do an aggregate analysis focused on like one particular aspect or one dimension of the system, you probably don't have enough data to do it. Dapper was really useful for the cases where they had, extremely high throughput, web search or ad serving, but for lower throughput products like Google Checkout, it had a much more limited value because they threw out so much of the data. They couldn't really make meaningful statistical statements about those systems. So if we review, there's these three fatal flaws for logs, metrics, and distributed traces. It's pretty much impossible to find a solution that is, let's say vanilla, a standard sort of logging or tracing or metric system that can scale gracefully, account for all data, and then is immune to cardinality issues. This in and of itself is, a major critique of this three-pillar mindset. There's a lot of companies that have deployed the three pillars and are still, in a world of pain and still having problems. We need to be smarter, not just personally, but as an industry about how we evaluate and think about observability products is not just these three checkboxes. Ultimately, there's no silver bullet here. If you were hoping that I had one, I'm sorry to disappoint you, but there are trade-offs in all systems and in all systems design, right? But we can sort of unpack it a little, and we can, if we change how we think about this problem, we can so overcome some of these challenges. So let's think about the difference between data and a user interface. As it sounds like a digression, but it's really not. So if I go into Google image search and I search for computer, what do I get back? Well, I'm not getting, the first two things here are actually monitors, right? If you look at where my circles here are, I searched for a computer, but I actually got back a picture of a computer monitor. So semantically, did it not really understand what I was trying to say, or is this a problem with the interface, right? You can apply that same sort of thinking to telemetry data or to statistical data about your system. Metrics and logs and traces aren't really separate types of, they're separate ways to measure things, but they're not really like completely separate. A good example of this is earlier I mentioned that I can take logging data and I can use logging data to create to get counts, right? I can use logging data to sort of create statistical data. Well, if I have structured logging data, then I can extend that even further, right? I can pick out certain parts of it, and then I can generate metrics out of my structured logging data. I can also do things like turn traces into metric data by looking at the length of time it takes to do certain operations. I can turn that into a latency, a latency histogram. I can take a log message. If I have some sort of correlation ID, you can take logs and turn them into traces. And the point I'm trying to make here is that when we go and we look at an observability or a monitoring product and we see, metrics, logs, and traces, those are actually just visualizations of raw data, and that raw data is fairly convertible from one form to the other. Metrics and logs and traces are important, but they're just data. They're not features. They're not use cases. We can collect all of those things and we can aggregate them. We can sort and search and do all sorts of stuff with them. But if we can't be intelligent about how we consume the data, then it's not really that useful to us. So I'm gonna segue into, if we spent all this time so far talking about these three types of data and these three pillars. If that's not how you should think about this, how should you think about this? So let's talk about a new scorecard, a new way to evaluate tools. Rather than thinking about this in terms of data sources and in terms of what kind of data we're ingesting, let's think about what are our goals and what are the activities that we're doing to meet those goals. So our goals are always related to how our services perform in the eyes of their consumers. Really, this is a user-centric view of the world, right? What you're monitoring, what you're looking at, needs to really be focused around the user experience. Now, in service of those goals, there are certain activities that we need to take as people that are running distributed systems or providing, monitoring services for engineers that are creating distributed systems. Those activities are really central to performing, to achieving those goals. So we can divide observability into these two core pieces, goals and activities. Before I continue, I want to do a quick refresher on some vocabulary. This is, I think, is one of the important things about observability as a concept, is that it's not just, tools, it's not just, practices, but it's also sort of the shared language that we can use to talk about performance. So what is a SLI? It's a service level indicator, right? This comes from the Google SRE book, or was popularized by it, I should say. And SLIs are simply an indicator of health that the consumer of a service would care about. So let's say I have a Kafka queue. An SLI for that might be how long does it take a message to get into and out of a queue for a particular topic. Now, you wouldn't really want to look at the CPU load or the number of nodes that you're running Kafka on as an SLI. Those are really just details about how Kafka is run. The key concept I want to get across here is that most services really have a very small number of SLIs, but those SLIs are incredibly important and they really need to be measured. If you can't explain which SLI that you're optimizing or that you're trying to move for an optimization that you're making, then you probably shouldn't be making it. Defining your SLIs is the first step to running a high-performing service. So there's two goals that observability leads towards. Going back to that goals and activities slide, you really are looking to gradually improve an SLI. And an example of this would be, your PM says, hey, our product's too slow, our service is too slow. So I'm gonna spend a quarter, or a couple sprints, doing optimizations and refactoring services in order to improve my baseline performance, right? Maybe I have some sort of, something that becomes, part of the critical path, and it's like on average, my P50 is 500 millisecond response time. We want to get that to 250, millisecond response time. So you're going to do a bunch of work optimizing database queries, and maybe you're going to do some re-architecturing of things. That's a gradual improvement, right? It doesn't happen overnight. It happens over the course of weeks or months. Now, the second goal is to rapidly restore an SLI. So let's say I've got my service is running fine. It has a pretty stable performance, but all of a sudden, something's out of whack. Response time jumps 2, 5, 10x, and it's impacting users. It's impacting people that are consumers of my service. So I need to fix that as soon as possible. Now, usually that means that I need to undo something, right? Maybe that was a push of data. Maybe that was a new release. Those are different things. And when we talk about observability tooling, if we talk about observability tooling without identifying which goal we're trying to move, then it can lead us into kind of the wrong headspace to make those decisions. One of these, as I said, takes days or weeks or months. One of these takes hours or minutes. So they're both important goals, but you need to think about which tool you're using to achieve each goal because they might not necessarily be the same. The two activities that we're pursuing in service of these goals are detect our SLIs and then refine them. So detection here is pretty simply, I want to monitor an SLI as a specific number. That could be something like P50 latency, although I generally recommend P99 or P90. Or we want to measure the throughput, or we want to measure the error rate. Refinement is about reducing the search space for whatever's going on. Before I get too much further into this, I want to talk about the frequency of statistics. So this is the same data, 4 different ways. The only difference here is that we have a smoothing interval that we're using to compute these percentiles. So this is P99 latency of an internal system at 1 second, 5 second, 10 second, and 25 seconds of granularity. So as you smooth out this over longer intervals, you're missing some outliers. I think the best, if you look from 1x to 25x, it's extremely noticeable. But you can see all those little, long tail sort of latency situations. If you are, excuse me, oversampling on statistical frequency, then you're going to miss sort of those interesting events that, one, are actually attached to end user experience, and two, could be extremely useful when you are trying to rapidly restore or improve your SLIs. If I look at the last one, it's hard for me to tell if this is like an intermittent problem or sort of a steady state regression, because it looks like the overall, latency has increased. However, if I look at the first one, I can see that this is indeed, extremely intermittent, and that's an important clue that would help me determine what I need to do to remediate this problem. So if you buy my argument here that observability is about, detection and refinement, then how do we weigh these things? How do we score observability products? Well, I don't want to say it's complicated, but here's these 3 things. Let's break this down because there's a lot here. So to detect something, we need to understand the cost of cardinality. A lot of times, people will say, cardinality is something that you can't just pay $1 for it. That you can't attach cardinality to costs, but I don't really think that's true. We just need to understand those costs. We also need to understand the stacked elements you can measure. So rather than focusing on just like, Java, a particular backend or database or whatever product, can you go into your mobile platform, your mobile client or your web client? Can you look into, managed services, managed databases, whatever else when you're measuring your services? If you're trying to improve your end user latency, none of this stuff can be off the table. You need to be able to see both, quote unquote, the front end and the back end of your, requests. Also, can you go below your application code? Can you go down a layer into sort of your frameworks, your, ASP.NET.MVCs or your Java Spring? Can you measure that? And then can you even go beyond that and go across the wire to like a managed service, a managed queue or API gateway or something? So, because our failures there propagating up the application stack to your end users, who knows? But the idea of specificity is about understanding, cardinality and the support of your observability solution at different layers of the stack. Fidelity means that your statistics are correct. So there's a lot of exclamation points here on correct stats because it's actually really hard to calculate like P99. A lot of things that people pay a lot of money for will take the P99 across different hosts and then average all those P99s together, which makes it statistically meaningless because I've now created an average and average. To get a statistically correct P99, I actually have to, compute it at the end. So you need to have been storing a histogram or a meaningful summary of your data in order to calculate true P99. So the takeaway on this point is really, if you're measuring P99, yes, that's good. That's very smart. That means you're not going to miss tail latencies. But a lot of times the P99 your tooling tells you is not actually P99. Now the other part of fidelity is, this high frequency, right? If you remember back to the last slide and the difference between like the 1x and the 25x, if you're going to try to automatically detect things or have alerting, then you really, really, really want the ability to detect the difference between an intermittent failure and a steady state failure. And that's only really easy to do if you have high frequency of data. Because as we showed, if you're, I'm just going to go back. Let's imagine I have alerting set up here, and that alerting is on, P50, or let's assume my line here, my line is whatever. But in the first case, I'm actually not going to trip a, high frequency, a high priority alert. On that last one, I might because the overall latency graph has increased over, 10,000. Whereas in the first one, I'm going to get an individual alert, or maybe I'm not, right? Because if I tune it to say like, well, that first one I can make an alert like if the count of requests over 10,000 is greater than whatever across some time window versus the last one, which is just if it's over 10,000. So if it's over 10,000, that might be an all hands on deck. In the first one, it's just like this is an interesting, outlier that I need to investigate. And that actually kind of goes to this last point on my scorecard here, which is the freshness of my data. So if I'm trying to fix a problem in real time or a problem that's impacting people, I want to make sure that the data I have in my observability system is pretty, pretty close to when it actually happened. So if I'm buying technology or I'm trying to build my own observability platform, and there's more than about 5 seconds of lag between when an event occurred and when I can actually see it, then that's going to be tricky. That's going to be hard to really see cause and effect. So why do we talk about refinement rather than anything else when we were talking about those activities? So when I add microservices to an existing microservice architecture, the number of things that my end users care, my end users don't really care about how many services it takes to do whatever it is that they are doing. If I am a bank and someone goes to check their balance, they don't care if it took one service or 100 services to show them their balance. They want to see their balance. So we have to accept that as engineers, that our beautiful microservice designs, haven't necessarily, they might have improved the performance of our software, but users don't really care about microservices. They only care about what they can see, which is performance. But the complexity that we've introduced with microservices means we've added a linear number of failure modes, and that number increases as we add more microservices. Service-to-service interactions introduce a lot of fun ways for things to break, and most of them are pretty elaborate and extremely hard to predict. So even if you could sit down and build a dashboard that had every possible failure mode on it, as just a human being, you don't have time to sit there. You don't have time or probably the energy to sit there and then manually drill down through everything. Oh, I've seen dashboards that have tens of pages and pages of spark lines and time series and roll ups and things like that, and it's completely useless because if there's a failure, failures tend to crop up concurrently in multiple different places. So you're going to be dealing with a bunch of different lines that are all spiking at the same time, and then you have to sit there and go through and kind of guess and check and see, like, well, is this one the one that has the problem? No, okay, go on to the next. And that's really painful. That takes a while. The crux of observability is that you can not only detect the problem, but then you can refine the search space. So we're not just going to find we're not going to find observability solutions that will both reliably tell us the answer and also fix the problems for us, right? We have to, we're probably going to be the ones that fix the problems. And if they ever do figure out a way to make an observability tool that fixes the problems, then a lot of us are going to be out of a job. But what tools can do is they can reduce the space that we have to look for the answer. They can make the haystack smaller. If you think about it as we're looking for a needle in a haystack, we can take a lot of straw out of that haystack. So we can reduce the search space and then refine it down to a set of credible and testable hypotheses. An observability solution should mainly act to eliminate hypotheses before you investigate them, so that the ones that are left over are the ones that are potentially, actionable. So we discover a variance in our systems, usually through some sort of SLI regression. We explain it using observability tools, and that explanation is usually in the form of a new variance that we then have to explain again. We can keep doing this until we either find something that we can fix, either by adding a cache or getting rid of a serialization or rolling back a release. We're looking for a variance that can be explained by a problem that we know how to solve. I also want to take this opportunity to talk about histograms a minute. So if you look at this histogram, this latency histogram here, this histogram is showing the latency for a single request, right? If it's a service called sellable, and you can see the operation name there. So the x-axis here is slowness. The further right you go, the slower you are. The y-axis is frequency. The further up you go, the more data there is. The P99 of this diagram is right here. You can see the line that has P99. But it's more useful, it's useful to know where that P99 is, but it's also very useful to understand the shape of the distribution. Histograms are the right way to do refinement of latency because you can observe multimodal behaviors more easily. Like a human being can look at this, pick out behavior, select it, and then sort of reduce the analysis to the mode they're concerned with. I really encourage you to think beyond just kind of percentile measurements and then think about visualizing the entire distribution so that you can find these different modalities and drill down into them individually. Because here, like I said, I can look at this and you can look at this and you can very easily see sort of interesting behaviors in this histogram for this request. You can see the relative, amount of requests that are happening at these different points of latency. And then I can go in and explore that and really try to understand why is it slower for these requests. So we talked about discovery. Let's talk about refinement, right? Here's the scorecard of how we gauge refinement. So for identifying variance, we've talked about cardinality, and cardinality is extremely important. It's arguably more important than detection. We need to understand how much money we're spending for more tag values. And we need some way to deal with metrics, right? We need some sort of, time series. We need things like host metrics. We need custom metrics. But we need to be careful about how much we're paying for them, because if you're using metrics to do refinement, then cardinality is the only tool you have to accomplish that goal. And again, cardinality is how many unique values I have for tags. So as I add more complexity, as I add more hosts, as I add more users or whatever else, I'm adding more cardinality. So second thing here is robust statistics. To me, that's histograms, right? Histograms are very important for refinement just because they allow you to reduce the entire set of hypotheses that you have to evaluate. In this case, we're only looking, in the case before, we were only looking at the top 5% of requests, and that's a nice thing to be able to kind of visualize and refine down to. We also need to think about our retention horizon, or in plainer words, how long are we keeping data around? This is extremely useful for explaining kind of what's normal and what's abnormal. A common workflow I find in microservices is that I find an issue and it looks bad, but I don't know, like, is it always like this or is this something extraordinary, right? If I don't have a system that tells me what I'm looking at compared to, an hour ago or a week ago or a month or a year ago, then it's hard to answer that question of what's normal. A lot of time series data is trying to answer this question of normalcy, but I think there's maybe some better ways to understand that question. Again, you see under explaining variance, correct stats, we talked about that, so I'm not going to harp on it. But I do want to get on the second point here, which is suppressing messengers. So if you look at the top right, we have this really simplified architecture diagram. So if I have a service in the top and that service depends on some intermediate service and that depends on some tertiary service, and the tertiary service fails, I don't want to blame the intermediate service for the failure, right? I don't, if these are A, B, and C goes down or C has a problem, it's not B's fault. Now, B will represent that failure in its own performance, right? Or its own lack of performance. So a lot of times people will get woken up or paged because there's an error latency issue somewhere down the stack, but we shouldn't waste a lot of time on intermediate messengers of that failure, right? If A, B, and C all have different service teams, like, do we want A, B, and C to all get alerted equally? Maybe not. What we want is for A and B to know that it's C's responsibility to fix this problem because the problem is coming from their service. So an observability system that can understand kind of the global picture should be able to suppress hypothesis for things that don't matter. I want to be able to search for only the services that are having a problem rather than services that are related to the ones that are having a problem. So let's talk about sort of the scorecard for observability. And first, I'll give you kind of a hint at how I tend to think about this. Let's play a game, right? You can have three of these. You can have a system that's high throughput, that supports high cardinality, has a lengthy retention window, or is unsampled. And you can only choose three here, right? You can choose three and no more. It's actually not possible to have all four. You can't have, infinite cardinality, extremely high throughput, lengthy retention window with no sampling because you will produce more data. The production of data becomes untenable and the storage data becomes untenable, and you are literally talking like NP hard sort of stuff here, right? Like you have growth that accelerates beyond the capacity of the system to record it. You need to figure out how to get all four of these by approximating things. This is the core problem. This is why there's a lot of activity in the observability space, right? Our CEO, BHS, refers to this as observability whack-a-mole. Now, I'm biased here, partially because I wrote a book about it, but I think tracing data is the best data source we have. Traces are a superset of log data, and it also understands context between services, which makes it very valuable to suppress hypothesis, right? It knows the relationship between service A, service B, and service C. So as a sort of raw material, tracing data can suppress hypotheses about parts of the system that are reflecting failures but aren't actually the cause of a failure. So tracing is useful, but this retention thing is really, really a killer here. A lot of approaches will retain 100% of the data for some period, and then we do a lot of fancy stuff to actually, a lot of fancy dynamic sampling to explain a hypothesis, which is a nice angle, but there's other approaches. It's not just the way we do it. So if we take this score and we kind of boil it down, these are the things you want to evaluate, right? You want to evaluate detection on specificity, fidelity, and freshness. You want to evaluate refinement by how are you identifying variance, lowering cardinality costs, accurate statistics, high fidelity histograms, retention horizons, strong context so you can suppress kind of intermediate failures. Now, again, I'm biased here, but I believe that Lightstep as a product has solved a lot of these problems. We offer, automatic detection of regressions by looking at deployments. We can take the contextual trace data you send, create system and service diagrams. We can do real-time and historical root cause analysis. We can provide correlations between all these things, custom alerting. It's all based on open source telemetry, so there's no vendor lock-in. And really, truly, honestly, there's no limitations on cardinality. You can have as many tags as you want. All that said, I've got some time here at the end for questions. But if you'd like to know more, you can go, we have a free trial. Check it out, go.lightstep.com/trial.
All right, great.
Thank
So
you.
there's plenty of time for questions. If you do have a question, please go ahead and use your GoToWebinar control panel, and we'll try to get to as many as we can. Let's go ahead and start with this one. It's kind of interesting. Extra points for the computer example. It goes to prove your point of not knowing what we are looking at. The first two items when searching for the word computer on Google, while they look just like look like just monitors, they are in fact all one computer. So that was kind of an interesting perspective there.
Yeah, I think it's, excuse me. Yeah, there's certainly a problem with the way that we tend to, and I'm probably as guilty of this as anyone. We tend to collapse a lot of things that aren't that seem like the same thing but really aren't, or we take things that are the same and split them up for varying reasons. Yeah. I guess another way to think about this is, how many times do you have a system that is just, converting data from one form into another? It's not just a problem in sort of the observability realm. It's something just more endemic about like how people process information. And I think a really good tool, this is actually one of the drawbacks, I think, to sort of machine learning and AI and stuff like that. The promise of machine learning is we can have a computer, sort of make a lot of these decisions and judgment calls for us, but all the computer knows how to do is sort of regurgitate things it's already been told. So a machine learning model is going to, compare an image to this huge corpus of other images, and it's going to say, well, that looks like a cat, but what if a completely novel cat exists, right? Then it's not going to be able to understand it as a cat. So I think that you see similar things with monitoring that promises, oh, we use AI or whatever. All it knows how to do is compare the state of your system to what it's seen before and has a difficult time dealing with truly novel sort of emergent behavior from complex systems.
All right, great. Our next question, will Lightstep give visibility on pods, containers, nodes, eviction, where at times during these evictions there could be a latency on M services?
So I will give you a qualified yes. The tricky part with that would be the instrumentation coming from the Kubernetes API or coming from Kubernetes itself. Like you would be able to, so if you had your application code instrumented and you had, the whole thing running in Kubernetes, then you would certainly be able to see sort of the second order latency there of a request taking longer under certain circumstances. What you would need to actually connect that to, an eviction in Kubernetes would be instrumentation that went down into Kubernetes itself. That I believe is coming. I think I've talked about the Kubernetes instrumentation SIG has talked about adding tracing in with OpenTelemetry. I don't know what the current status of that is. I know a lot of things kind of got thrown back into the air due to the pandemic in terms of work timing for this year, but I know they're very interested in it. And I think I know Google had some interns working on it like a year or two ago. So I wouldn't be surprised to see in the near future, better tracing support in the Kubernetes API and for sort of container lifecycle stuff like that. And that would make it very easy to see. But, we would help you. We could certainly help you see sort of, you could also figure it out, right? If I had, you compare two traces or compare a group of them and see like, oh, these are the one, this took longer, and I can see that the host, the node is different now, right? There's a couple different ways you could do it.
Okay, all
Really
right.
good question.
Excuse me. Yeah, lots of good questions here. Next one. Hi, Austin. Nice presentation. I was wondering about the roles of apps profiling to get some SLI to start digging the root cause if needed, when needed. What is your opinion about this?
What are the roles of apps profiling? Sorry, I'm trying to understand the question a little. So I think if this is the wrong, or if I'm not understanding the question, please feel free to reach out and I can answer it for you again. But I'm a big fan of profiling in production. So most of the time I don't think we need like incredibly deep profiles unless there's sort of a very specific issue happening that we need like really low level latency, really low level information about. If you have sufficient instrumentation in your application in sort of the, web client or iOS client or Android client or whatever, then that'll give you a really solid idea of like what are people experiencing, what is the user experience like, right? And that helps you refine down to find that sort of long tail latency, find those sort of outliers, and then you could go in and say like, okay, well now we need to do deeper profiling, right? Now we need to get a capture of syscalls or whatever else, and look at how long is it taking to paint this element onto the canvas? How long is it taking for the DOM to render, right? There is a trade-off, I think, in instrumentation that you want to run kind of all the time versus the stuff that you want to run, on demand or separately. And it is going to depend on sort of your use case and on the problems that you're seeing. So if that wasn't quite what you were asking, feel free to reach out to me, and I can take another stab at it. But I think that's what you were asking.
Okay, all right. Let's see. I think we have time for one more question here. Let's see. We recently deployed services on a microservices architecture utilizing containers clustered up and managed by Kubernetes. Service observability is through a Prometheus tooling facility. What do you generally think of Prometheus in this regard?
I mean, I think it's great, right? Like I have no problems with Prometheus. The and in general, you're not gonna find me like saying a bad word about any of like the open source tools here because I think they're all, they're good. The problem, it really comes down to like a value add, right? Like there's a lot of stuff you can do in Prometheus and in Jaeger and in Elk Stack, and you can get these basic sort of, I can ingest these data sources and I can make queries and I can do stuff like that. But at some point, you're gonna want more, I think, and you're gonna want to be able to, have some features that will do things like tell you, hey, these two things are strongly correlated, right? Like if I have um, one good example. Let's say I'm rolling out a new version of something, right? Like I've got a new release of a service in my cluster, and I'm rolling that out, and I'm doing a canary. Um, I can go through and in Prometheus and other tools, build dashboards and build queries that will help me see these sort of things, right? They will help, but it takes time that I could be away, that I could be doing something else. In Lightstep, we can automatically detect, a new release of a service and give you this really in-depth report in real time of, what percentage of traffic is going to the old version versus the new version? What's the difference in my SLIs between these two versions? What's strongly, do I see the error rate going up? Well, is that error rate going up in the old version or just in the new version, right? And that gives me information that I need in order to make a decision of, do I cancel the rollback? Do I cancel the release? Do I roll back? Or is the new release actually fine, right? And it's the spike in error rates is actually starting to correlate with something else, right? Maybe I'm doing a new release and at the same time, there's a node, a pod is being evicted from a node because
Mhm.
of some other thing, right? These are the complex interactions that I'm talking about. So that
Okay.
said, you can certainly use open source stuff to do a lot of this, but I would encourage you to look at tools like Lightstep to really kind of supercharge your monitoring and also save you the trouble of having to build all this stuff yourself. We have a lot of
Okay.
people that get paid a lot to think about these things, and hopefully will you know be able to come up with something maybe better, or at least more that have thought about things that you haven't thought of.
All right. Well, we are about 3 minutes to the top of the hour, so unfortunately we don't have any time for any more questions. But if we didn't get to your question, I apologize, but please know that Austin and the folks at Lightstep are going to be getting a copy of all of the questions, and I'm sure somebody from the organization will be more than happy to follow up with you offline to get your question answered. Also want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, before we close things out, I do want to do the drawing for the two $50 Amazon gift cards. So without further ado, our first winner today is Lawrence C. Congratulations, Lawrence. And our second winner is Jerry P. Congratulations, Jerry. We'll be following up with both of you via email to get your gift card over to you. So please check your inbox. Excuse me. Should be there pretty soon. Austin, thank you so much for a great presentation. Good stuff, as always.
No problem. Thank you very much for having me.
All right, all right. And I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and stay safe.